Hi everyone, this is a quick video lesson on how we can use a spreadsheet to simulate some probability type experiments. In particular, we're going to be looking at a new game that I've invented called 3-Up. It's like 2-Up, but instead of throwing 2 coins in the air, you throw 3 coins in the air. Now, I have to decide, I'm going to do some theoretical calculations here. I have to decide which events are going to be winning events. Now, I think if we get 3 heads, that should be a winning event. I also think if we have 2 heads, that should be a winning event, and everything else will be a loss. So that would be 1 or 0 heads showing up. Let's just type that a bit better so that it fits neatly. 1 head, 0 heads. I still need to do this. Oh, it's all right, I'll just make that column a bit wider so it fits nicely. Now, as this is a very simple game, I can work these probabilities out straight away. The chances of getting 3 heads in a row, well, there's only one way that can happen if all 3 of them turn up heads, and the chance of an individual coin landing on heads is a half. So a half times a half times a half is 1/8, or 0.125. That shouldn't be money, that should just be normal old numbers, please. And let's have a slide. Yep, there we go. Now, what about the chance of getting 2 heads? Now, this is where we have to start thinking about combinations. How many different ways could the coins land if of the 3 coins I'm choosing that 2 of them are heads? So 3C2 is that's 3, and each of the outcomes is a half times a half times a half. Whether it's a head or a tail, it's probability of half. So it's basically 3 times that number there, 0.375. And again, somehow that's turned into money. Let's have that as a number, please. Now, what are the chances of getting the other outcomes? Well, it has to either be 3 heads, 2 heads, 1 head, or 0 heads when you throw the 3 coins. So the losses are the complementary event. If you add these two, you'll see they come to 0.5. So that means that it's a 0.5% chance. For some reason, everything in my spreadsheet thinks that it's money. That's annoying. Let's just do this and make sure that everything is just a general format. So that's good. Now we have to decide the payout on these different outcomes. I'm going to assume that the players make a $1 bet. So pretty much, oh, now this one could be money, couldn't it? Okay, so if the players make a $1 bet and they lose, then their payout is -$1. The casino keeps the money. But let's make some, well, I'm not sure exactly what these ones will turn out to be. Let's give this a prize of a $3 payout, and let's give this one a $2 payout. Again, I'll make those ones into money. Now, the return to the gambler. Well, that payout only occurs, we expect, 1 turn out of every 8. So the return to the gambler is the probability of the event multiplied by the size of the payout. So on average, we would expect that occurrence, the 3-head event, to give a payout of 38 cents to the player. Likewise for this one, we'll go this number multiplied by the $2 payout. Oops. So that's actually going to be a more profitable event. The player, because it's only a $2 payout, but because it occurs much more often, on average, that event pays 75 cents to the player. And lastly, we'll do this one multiplied by this one. And we get that. Now, these things that are money, I would just like to format those. If I put currency, I can format the negatives to be in red. It just makes them stand out a bit. Now, what is the this is the total return to the player then. I'll have the sum of these numbers. Now, that's good for the players because it's a positive number. On average, the player is going to get a payout or a return of 63 cents every time they play the game. That's not good for the casino. What that means is I need to lower the size of the payouts for the winning outcomes. I'm paying too much. What if I paid $2 for this one and $1 for this one? Now, that's still giving a positive return to the player. I'm still have prizes that are too much. So maybe I could lower this one to $1.50. Sorry, that was supposed to be $1.50. And this one could be 75 cents. That's more like it. The player is now losing 3 cents for every dollar they bet. In other words, so this is the player loss. In other words, the casino profit. And let's just format that to read like that. Now, what about the house edge? The house edge is literally how much the house collects or wins, in this case 3 cents, compared to the amount the player bet. The player bet $1. So that is literally a 3% profit. I will go -1 multiplied by that number, so it's now a positive number, and I'll format that as a percentage, and I might give one extra decimal place. Now, a 3.1% house edge doesn't seem like very much, and it's not for an individual game. But if we can convince people to play thousands upon thousands of these games, then this will actually end up being a very profitable outcome for the casino. In the long term, they'll collect 3.1% of all the money that gets bet playing this game. And if people bet a lot of money, 3.1% is still a significant amount. Now, as a casino, some games have house edges which are about sort of 3 to 5%, but others have much higher house edges. If I reduce this one, now I can notice here on the returns, you see how the larger payout of $1.50 is actually not as profitable for the gambler because it doesn't occur as much. This one with a 28% return is much more profitable to the gambler and therefore costly to the house. If I wanted to increase my house edge, this is the one I will target because it's the one that's hurting me the most. So I might make that a 50-cent payout. That's more like it. I've now got a 12.5% house edge, which is pretty much what most of the gambling games are, between 10 and 15% house edge. So that's enough for now. I've done a theoretical calculation on a very simple game involving throwing 3 coins. In my next video, I'll start to build a simulation of this where we can use random numbers to actually run the game and see if our calculated or theoretical house edge matches experimental probability. Thanks for watching.